I'm Rory.
I'm Zoe.
And I'm Josh.
And we are part of Team 359A.
We will be explaining the intricate details of how math is incorporated into our Gyro Sensor program by asking questions. We want people to understand the steps in order for the gyro to work and why the gyro sensor is important.
Gyro sensor, otherwise known as a gyroscope, is a wheel or disc mounted to spin rapidly around an axis, and also free to rotate about one or both of two axes perpendicular to each other.
The gyroscope was invented in 1852 by the French experimental physicist named Leon Foucault as a part of a two-pronged investigation of the rotation of the Earth.
A gyro sensor consists of a central wheel or rotor that is mounted in a framework of rings.
Computer pointing devices uses a gyro sensor by tracking your hand movements. Racing cars also use a gyro sensor by helping the car balance. Virtual reality has a number of miniature gyroscope sensors that are placed in the headset, so whenever the user moves their head, the direction and speed is sent back to the computer.
We use the gyro sensor when we want the robot to center itself and when we want the robot to H-drive while correcting itself. Overall, the gyro sensor corrects our robot so we can have more accurate results in our autonomous.
The gyro sensor works by first finding the error that the robot makes per millisecond. Then, the gyro will find the correction and correct itself.
Before the gyro sensor, our robot was a lot harder to program. Especially with Omni wheels, our robot would always drift off to the side, which is a big problem because autonomous requires a lot of accuracy. And because our robot drifted, it was never really accurate.
When we added in the gyro sensor, our robot stopped drifting. What the gyro sensor did was that it found the error per millisecond, then it calculated the correction, and then corrected itself.
We ran into a big problem while programming our gyro sensor function. While the gyro sensor corrects itself, the robot will move left and right.
We thought that if we increase the number of degrees the robot will turn while correcting itself, and also increase the speed that it turns, then the robot will correct itself much faster. But actually, the robot took much longer because it would skip over the correct value and it would just keep turning left and right, not continuing on in the program.
Instead of increasing those values, we decreased them. That helped out a lot with shortening up the amount of time the robot took to correct itself.
Step 1. Find drift. After 5 seconds, we read the gyro. Anything we read is drift because nothing is moving. In our case, we read 3 degrees error. But to make it easier to understand, we will use 5 degrees. The gyro error is equal to 5 degrees divided by 5 seconds, or 5,000 milliseconds. So in this case, gyro error equals 1. Step 2. Correcting for drift. This time, we added a touch LED. The touch LED will start off red and will then turn green after 5 seconds. While the LED is red, it's finding gyro error. After 5 seconds, the touch LED will turn green and we will now have gyro error. Now, we have to solve for gyro correction. To solve for gyro correction, you take gyro error and multiply it by the time that has passed so far. All of these steps work towards finding gyro value. Gyro value is the value that we get after adjusting for drift. We find gyro value by subtracting gyro correction from the gyro sensor. And now, we have gyro value.
The gyro sensor helps with getting the robot to its exact destination, as well as that it helps with the robot being straighter and more accurate.
The gyro sensor is difficult to program as well as that sometimes it takes long for the sensors to calculate the correction. With speed measurements, computing movement degrees, and using programming functions to condense our code, our gyro sensor is a vital part of our robot's autonomous program.